This is the second video on chemical reactions. This is on balancing chemical reactions or the application of the law of conservation of mass. Remember that the law of conservation of mass states that in a chemical reaction, you cannot create or destroy matter. That means the total mass of the products must equal the total mass of the reactants, because the number of atoms of each element must be the same on both sides of the arrow. There are 4 rules and 1 comment for balancing chemical reactions. You can only use the chemical specified. You cannot change a subscript. That would change the chemical, which would violate Rule 1. You can change coefficients. Quick reminder, no coefficient in front of the chemical. The coefficient is 1. And at the end, all coefficients must be in the lowest whole number ratio. The comment, we are conserving atoms, not moles. The easiest thing to do is to do a couple of examples. The first is having propane and oxygen react to make carbon dioxide and water. I am going to color code each of the elements, and then I'm going to use a particular diagram to visualize what's going on. The vertical line obviously separates the products and the reactants. Going to set up a table with reactants on one side and products on the other side to keep track of how much of each I have. I then begin to list the elements. I start with carbon. I have 3 blue dots on the reactant side, 1 on the product side. Hydrogen, 8 on the reactant side, 2 on the product side. Oxygen, 2 on the reactant side, 3 on the product side. Now I'm just going to pick an element and begin to balance, because I want to get the numbers on the reactant side and the product side the same. A quick hint, if one of the chemicals is a pure element, balance that last. It's much easier that way. So I'm going to start with the carbon. I need to get 3 blue dots on the product side. So to do that, I need 3 carbon dioxides. So I add 2 more. And when I do that, I have 3 blue dots on the product side. But I've also changed the oxygens. I now have 7 on the product side. Don't worry about that. It'll all work out in the end. Now I go to hydrogen. I have 8 on the reactant side, 2 on the product side. So I'm going to add 3 more waters. When I do that, I now have 8 hydrogens on the product side and 8 on the reactant side. But I now have 10 oxygens on the product side and only 2 on the reactant side. But if I add 4 more oxygens to the reactant side, I now have 10 oxygens on the reactant side, and I see that for carbon, hydrogen, and oxygen, I have the same numbers. I'm balanced. So I would write it out this way, and that would be my properly balanced chemical equation. So now let's try it with sodium sulfate, aluminum chloride, and that becomes aluminum sulfate and sodium chloride. I'm going to color code and particulate diagram it again. But note, because the sulfate, the purple, is the same on both the reactant and the product side, it can be represented by a single dot because it is 1 ion. I don't need to break it down into its elements. But that's only if it's the same on both sides. I go to set my table up. For my sodium, I have 2 on the reactant side, 1 on the product side. For the sulfate, 1 on the reactant side, 3 on the product side. For the aluminum, 1 on the reactant side, 2 on the product side. And for the chlorine, 3 reactant, 1 product. I pick one and go, and I'm going to start with the sodium. Since I have 2 on the reactant side and 1 on the product side, I'm going to add another sodium chloride. When that happens, I now have 2 sodiums on both sides. The chlorine now has 3 on the reactant and 2 on the product. It'll all work out in the end. Next, I go to the sulfate. I have 1 on the reactant side, 3 on the product side, so I'm going to add 2 more sodium sulfates for a total of 3 sodium sulfates. When I do that, I see that I have 6 sodiums and 3 sulfates. So I've balanced the sulfate but thrown the sodium out of balance. Once again, don't worry. I go to do the aluminum. 1 on the reactant side, 2 on the product side. So I add another aluminum chloride, and when I do that, I have 2 aluminum. Now I have 6 chlorines. So my aluminum and my sulfate are balanced, but my sodium and my chloride are not. But when I look at the product side, I see that if I add 4 more sodium chlorides, I'll now have 6 sodiums and 6 chlorines. The numbers on the reactant side are the same as the numbers on the product side, so I'm balanced. So the properly written balanced equation would be this. There are multiple methods of balancing. Whatever works for you is fine, as long as it's properly balanced. So to review, balancing chemical reactions is really just an application of the law of conservation of mass. The total mass of reactants has to equal the total mass of products. You're conserving atoms, not moles. The number of atoms of any element must be the same in reactants and products. There are the 4 rules. Only use the chemicals outlined in the problem. Never change a subscript. That violates Rule 1. Only change the coefficient, and the coefficients must be in the lowest whole number ratio. In the next videos, we're going to start tackling stoichiometry.